An equilateral triangle has all three sides to be of equal length. The three angles within the triangle are also equal as well, in this case 60 degrees. So we can also split this triangle up into two equal portions such that there's 60, 30 and 90 degrees. So with this in mind, we can actually figure out some properties for trigonometry. So over here, instead of x, I have length 2, and therefore this here is length 1. Similarly, I have 60 degrees and 30 degrees. Now, to be able to find the length of this straight line, using Pythagoras theorem, that would just be the square root of 2 square minus 1 square. Simplify that, that would give you a square root of 3. So this here has a length of square root of 3. This will then give us some properties of trigonometry, mainly sine, cosine, and tangent. So to be able to use sine, cosine, and tangent, I'm going to use the idea of Takaso. So Takaso means that, for example, if we have sine of 30 degrees, that is just the opposite over the hypotenuse. So in this case, if we are referring to this triangle here, this is our opposite, this is our hypotenuse, and this is our adjacent. So opposite over hypotenuse, that is length 1 divided by 2. Whereas for cosine 30 degrees, that is adjacent over hypotenuse, so therefore square root 3 divided by 2. Lastly, for tangent 30 degrees is equal to opposite over adjacent, so 1 over square root 3. Now, if we are no longer talking about 30 degrees, but instead we are referring to 60 degrees instead, then we can use the same triangle, but now our opposite is the red line, our adjacent is this, and this is still our hypotenuse. So sine 60, that is just opposite over hypotenuse, so square root 3 divided by 2. Cosine 60, that's adjacent over hypotenuse, so 1 over 2. And lastly, tangent is opposite over adjacent, so square root 3 over 2. Square root 3 over 1, which can be simplified to be just square root 3. So from here, we can figure out the sine, cosine, and tangent of 30 degrees and 60 degrees without any calculations. Now you may wonder, what about 45 degrees? Well, that's simple. It uses the idea of isosceles triangles. So if I have an isosceles triangle, and I have this to be length 1, this will be length 2, square root 2, as per Pythagoras theorem. Similarly, this is 45 degrees and this is also 45 degrees. So if I want to calculate the value of sine 45 degrees, that would just be opposite over hypotenuse, which is 1 over square root 2. Similarly, cosine 45 degrees, that is adjacent over hypotenuse, and that will give me 1 over square root 2 as well. Lastly, tangent 45 degrees, that's 1 over 1, which will be simplified to be 1.